That's right, Alexander. And it's said that any minute now, Dr. Math is going to come out of Dr. Math Studios right behind me, and he's going to be addressing the country on what the heck is a sample space. Back to you. All right, mathletes, so let's go ahead, let's do this. Let's talk about sample space, all right? Because it's a key idea in so many areas in math, especially statistics. All right, so we have some definitions here that we're gonna utilize, and then we're gonna do plenty of examples so you get an idea, and then I wanna encourage you to do these examples with us here. All right, so let's define what the heck a sample space is. Well, a sample space, as you see here, is the set of all possible outcomes. So if we were to do something, or if we were to conduct an experiment, what are all the possibilities? And we list them all out. That's a sample space, all right? So traditionally, what's thought of when we look at sample space is maybe tossing a coin, because we want to start off slow, right? So when you toss a coin, what could happen? Well, number one, you could end up with a heads, or you could end up the coin could end up landing on tails. So that would be our sample space of size 2 here, all right? And the sample space, when we're talking about it, some textbooks are gonna put S, all right? So make sure you read your textbook to see how they want you to label it, all right? And when we're counting the size, right, of the sample space, usually we denote that with an N. So we say here the sample space is of size 2 because there's 2 possibilities. All right, let's go to number 2 here, rolling a 6-sided die. So you roll the die, let's go 6. All right, so you roll that die, and what are the possibilities? Well, it could land on 1, 2, 3, 4, 5, and 6. So another good idea, another good example, you know, all the possibilities. And we're keeping it simple because we're gonna complicate things in a few minutes here. All right, but just to make sure you have that foundation and you know what it is we're talking about. All right, and be ready, I'm gonna be calling on you guys soon. All right, next, number 3, drawing a marble from a bag that contains 2 red, 3 blue, and 1 white marble. So we pick one. What are the possibilities? Well, we have 2 reds, 3 blues, and a white. We could put commas between all those, right? And if you want, what we could do to distinguish between those red marbles is you could write R1 to represent that first red marble, R2, B1, B2, and so forth, B3, just so you know the different marbles that we're looking at here, all right? But again, depending on your textbook, how they want you to label things, just make sure you follow their examples. All right, so there's our sample space, all right? So now let's get some ideas, let's get some practice so you can put this into action. Follow me. All right, so let's go ahead and let's build this up. All right, so we already did number 1, because if you notice, they want a sample space for this experiment, and you have a 2-headed coin, and it's gonna be tossed 1 time. Notice, it's 2-headed. So what that means is on both sides, it's heads. So when you toss it, no matter how many times you toss it, it's always gonna end up being heads. So in this case, the 2-headed coin tossed once is always gonna land on heads, right? So in this case, our sample space is only H, which represents heads, all right? So always make sure you understand the situation, because the sample space at times might be tricky. All right, let's look at number 2, mathletes. So 2 ordinary coins are tossed. So let's get some help. Jay Quallen, help us out, Jay Quallen.
Yeah. Do you mean Jacqueline?
Oh, I see how it is gonna be. I see exactly how it's gonna be, Jay Quallen. All right. All right, so let's look at this. So 2 ordinary coins are tossed. So if I toss a coin, well, 2 coins, excuse me, I could get a heads, and then I could get another heads, right? Or I could get a heads, and then the second one could be a tails. Or I could toss it, the first one being tails, and then it landing tails again. And our last option is tails, and then it landing heads. So in this case, our sample space, we have 4 different possibilities. So there they are. So we got a heads, heads, we got a heads, tails, we got a tails, tails, and we got a tails, heads. And here's a pro tip for you mathletes, right? Because as these get more complicated, how do you know that you actually found all of them? Well, check this out. When you toss a coin, how many possibilities were there? Well, there were 2, right? So that's gonna be our base. How many times did we repeat that action? Well, we tossed 2 times, right? Because 2 coins are tossed. So that's gonna be our exponent. And so we end up with 4, and that's exactly how many elements that we have here in our sample space. Write that down, because that's all right. Number 3, 3 ordinary coins are tossed, right? So let's see here. We're gonna have 2 options, right? 2 outcomes, either heads or tails. And how many times are we gonna perform this action? Well, in this case, we're gonna report the action 3 times. So it's gonna be 2 times 2 times 2. So we're gonna have a total of a sample space of 8. So make sure you use this and you write this down. So let's take a look at all the possibilities. So you got heads, heads, heads. You got heads, heads, tails. You got heads, tails, heads, right? See how easy it is to miss them? You got heads, tails, tails, right? And now when we're listing our other options, starting with tails, what I'm gonna do is I'm gonna take all these H's and transform them to T's, and all the T's transform them to H's, and that's a little shortcut that you only get here in Dr. Math Studios. So here, my friends, is a listing of our sample space. So let me go ahead and list all of them for you. And here what you're gonna do is we're just gonna transfer all of them separated by commas, right? In our set notation here. There we go. All right, so again, all you're gonna do is take 1, list it here. Take 2, list it here. Take 3, list it there, and so on. So it looks just like this. And what you're gonna see is we have a sample space of size 8. All right, mathletes. So if this is making sense, give me some love, smash that like button, subscribe, and we're not leaving you empty-handed. So try these harder problems, and we're interested in seeing what you guys think.